This video is on linear models and piecewise models. A linear function describes the relation between two variables where there is a constant rate of change. So we've already looked at linear equations, which we can convert to linear models when we put it into a context. So here is just a quick example. So it's been observed that under specific meteorological conditions, as dry air moves upwards, it expands and cools at a constant rate. The graph below shows the air temperature, capital T in degrees Celsius, as a function of the height in meters above the ground. The linear formula for this graph is the temperature equals negative 0.01x plus 20. Now with these questions, it is quite often to be asked things to do with what parts of this equation represent. So here we've got what does a gradient represent in this context. So what does that negative 0.01 mean in the context of this question? And for this one, it would be that it is the decrease in temperature per meter. So that the temperature decreases by 0.01 for every meter of height increase. Then the second part, what does a y-intercept represent? So the y-intercept is when the meters equal 0 and it is at 20. So in this situation, it is the initial temperature is 20 degrees. That's what the y-intercept represents. So you have to be able to look at a question and apply the context to the question to be able to explain. You can't just say the gradient is negative 0.01. You have to be able to say what does that mean in the context of the question. Example 1, taxi company A charges 80 cents for every kilometre travelled, while taxi company B charges 45 cents for every kilometre travelled, plus a fixed amount of $7. For each company, create a linear function that models the cost as a function of the number of kilometres travelled. So for company A, they charge 80 cents for every kilometre travelled. So the cost of A would equal 80 cents of 0.A multiplied by X, which is the kilometres. Nice and easy. Now for company B, it charges 45 cents for every kilometre travelled plus a fixed amount of $7. So for company B, it charges 0.45 per kilometre plus a $7, which is the fixed amount. Part B, which company would you choose for a ride of 15 kilometres? Justify your response. So what we want to do is find out what the cost is for each of these at 15 kilometres. So for company A, the cost would equal 0.8 times 15, which equals $12. For company B, it will be 0.45 times 15 plus 7, which equals $13.75. So with this information, we can then say we would choose company A because it is cheaper. Now, when we're doing justifications like this, we always try and include the numbers in our justification. So we want to say choose company A because it is cheaper at $12 compared to $13.75. Also then shows you've done the working out to fully justify your response. Then part C, find the point of intersection and interpret the values. So from here, we're going to go to the calculator, we're going to find the intersection point and then look at what those values mean. To find the point of intersection, we're going to go to a graph page. On our calculator, we're going to put in both equations. So equation A was 0.8x. And then remember to press that tab button above the control to get the next equation in. And our next equation was 0.45x plus 7. Press enter, we've got the next one. Now here you can see we can't see the intersection on this graph, so we have to play with our zoom. So if you go to menu, window, and you've got different zoom settings. For this one, I'm just going to try a zoom out. And now I click up here somewhere, and now I can see my intersection. So from here, we can then go menu, analyze graph, intersection. Remember, we've got this dotted line, click it before and after, and we can see the intersection there is 2016. From the calculator, we found the intersection point was 2016. Now, what does that mean? So this means that at 20 kilometers, both companies will cost $16. So at 20 kilometers, both companies cost $16. So therefore, after And if you can see this on the graph, after 20 kilometres, company B will be cheaper than company A. If we just draw a quick sketch here of what it looks like, company A goes like this, and then company B starts a bit higher, but then goes that way, and this is our intersection point of 2016. So we can see then, after this intersection point, the red line, which is company A, is more expensive than company B, which is then, after that point, the line is below the other one. Now, if we look at piecewise linear models, so a function whose graph is made up of line segments is called a piecewise linear function. I'm going to go straight into examples to show what this looks like. So in this example, we've got the piecewise function, f of x equals. Now with the piecewise, we'll always have this like big bracket, and we'll have two, you could even have more, 3, 4, 5 different parts to the function. Here we've got two. We've got the first function, which is 4, between the domain of -2 and 3. Then we have the next function, which is -x plus 7, between 3 and 7. And we want to find first f0. So when we're looking at this, we want to find the function when x is 0. We look at this piecewise, and we want to see which one of these two domains does 0 fit into. And it fits into the top one between -2 and 3. So then we want to put 0 into our equation, but here our equation just equals 4. So our function at 0 equals 4. Now for part 2, we want to put the function when x equals 6. Have a look where does it fit into? It fits into the second one of -x plus 7. So we're going to put 6 into this equation, so we'll end up with -6 plus 7, which is equal to 1. So the function when x equals 6 equals 1. Part B was saying to state the domain. We have two domains here. We have the domain from -2 to 3 and from 3 to 7. So the domain for this whole function will be from -2 all the way up to 7. Now we want to plot the graph. So the first part from -2 to 3, our graph is just 4. There's no x involved, which means because it's just y equals 4, it's a horizontal line between -2 and 3 at 4. It is just a horizontal line like this. Now between 3 and 7, it is -x plus 7. So now we need to plot that from when x equals 3. So a really good thing to do here to work out some points on this line, if we want to work out the y when x equals 3, so y equals -3 plus 7, which equals 4. And we know that's already the starting point. Because we know this is a linear line, if we look at the last number in the domain, which is 7, and we work out what this is when x equals 7, it equals 0. So between the start and the end point of this domain, the line has to go from the start all the way down to 0, because when x equals 7, y equals 0. So that is what this graph would look like. Example 2, the graph below shows the relationship between the temperature of a liquid T measured in degrees C over time T measured in minutes. Part A, what is the initial temperature? Initial temperature is when time equals 0, so the start, which is right here on the graph, I've just circled it in purple. So initial temperature is 120 degrees Celsius. B, state the time required for the temperature to reach half of its initial temperature. So the initial temperature is 120, so we're wanting to look when it gets to 60. So we can just read that off the graph, temperature across to 60, read that down to the time, and we see that is 30 minutes. Part C, state the time required to reach 0 degrees C. So then we can just look at the graph where it is 0 degrees C is here at time 40. So it takes 40 minutes to get to 0. And part D, create a piecewise function that models the given graphs. So we've got two lines there. We've got the first line, which is the blue, and the second line, which is the red line. So we need an equation for both of these. So for the blue line, we know the y-intercept is 120. Now we need to know the gradient, because it's a straight line, so it's y equals mx plus c. Because we have the line draw here, we can just do the rise over run. And it's going down by 60, so for the blue line, which we'll call that number 1. So the gradient of this is going downwards, so we know it's going to be negative. And then can do another way of doing the gradient without the formula is also rise over run. So in this case, we can use that because we can see with this blue line, the difference between the start and the end is 60. And then the difference between the x start and the end of that line is 30. So the gradient is just going to be -2. This piecewise model will have capital T because that's our y, little t in the brackets because that's our x value, equals. We do our nice little long brackets. That first equation will be -2. Now we're going to use t here because that's our x variable, plus 120 because that's the y-intercept, and the domain of this equation is from when t equals 0 all the way up to when t equals 30. Now the second equation, which is the red line, we know this starts at 3060 and ends at this quadrant here would be 40, 0. Now our gradient of this line, once again it's going downwards, so it's negative. The rise, so the distance between the bottom to the top of this goes from 0 to 60, so it's going to be 60 over. The run here is going from 30 to 40, so it's 10. 60 divided by 10 is -6. This one though, we don't know yet the y-intercept or what that will be the c value, so we need to work that out. So if we just put it into the y equals mx plus c equation, put in a point, so if we put 0 equals -6 times 40 plus c, work this out, and we would end up with 240 equals c. So our next equation would be -6t, because we are looking at time as our variable, plus 240, which would be the y-intercept if it was possible. Then our domain of this function starts at 30 and goes all the way up to 40. Now something to be mindful of here is the inequality sign here and here for the 30. We can't have 30 included in both equations. Now because we don't know which one is at the equal 30 part, we can just decide which one we're going to have less than or equal to and which one's just going to be the less than sign. And that's the end of this video.